I'm Marcy Ewald. I am the COO and co-founder at Think Nimble. We are a development agency that helps non-technical founders become confident leaders of technical organizations. And our goal is to help people build apps the right way. In the last 6 to 8 months, we have helped close to a dozen companies implement AI and different pieces of machine learning at their companies. Our goal today is to give you pieces of vocabulary that are really useful as you speak to developers about AI, and then also to start brainstorming a little bit about how you can actually implement AI at your company, and then how you can think about the right way to implement AI at your company and how you can leverage some of the tools that are available now. Presenting with me today was William, my co-founder at Think Nimble. William, do you want to give us a quick background on your interest in AI and how you came to learn about it?
Yeah, sure thing. I'm co-founder of Think Nimble with Marcy and Neil, our CEO. My role is CTO and build a lot of apps. I think going on pretty close to 100 apps over the past 10 years. That's my credentials. That's what I've been involved with. But in the background, I grew up in a household with two biostatisticians. Both my parents studied biostatistics. And so from a young age was exposed to different approaches to analyzing data and thinking about statistics, which is sometimes a non-intuitive thing. And that really cultivated an interest in that for me. And as I got into startups, that interest expanded out both into thinking about data analytics for software and marketing and things like that. But then also this machine learning thing has always been in the background throughout the entire course of my career. And of course, it's been gaining momentum over the past 10 years. And so I've been, for a while, was casually learning about it. And then in the past 2 or 3 years or so, got more serious about understanding how this stuff works, how we can apply it in applications right here, right now, today. And then, of course, in the past year, things have just exploded in terms of interest. So I'm ready to go and build some more apps now with AI. I just hope I can share some knowledge that's helpful to all of you where you're at in the stage of development for your companies or for the products that you're working on.
Awesome, thanks. And we have a mix of folks today on the call. And so part of the way we're going to structure this conversation is in a Q&A format. I know that sometimes talking about AI or even normal technical terms can feel inaccessible to people who are less technical. And I know sometimes conversations like this do surface level for folks who are more technical. So our hope today is that we'll structure a Q&A where I ask William questions and he responds with both technical answers. I break in where I feel confused or lost, right? And others can do so as well. And our hope is that that provides the context that you need to know how to talk about this. Again, once you start talking about it, it opens up a lot of doors for the ways that you'll have these conversations. And so hopefully you can leave with the vocabulary that you need to have these hands-on conversations with folks in your own organization or with other developers that you're working with. In this hour, our goal is to really cover what is AI, right? Generally, there are some very clear examples of it that everyone's talking about, like ChatGPT, OpenAI, lots of different organizations like that. But I think sometimes the words get conflated and they're a little bit confusing. And so we're just going to start with a really quick overview of what is AI and what should you know about this. Then we're going to talk a little bit about why you should care about it. So what's interesting about the topic for you as a business owner? What's interesting for you as a CTO, applying the different business lens to the technology sphere. And then finally, we'll talk about how you can actually build AI and apply it to your business. The different structures in this are going to go through the superstructures around the vocabulary that we need so that by the time we hit the end, we can brainstorm about different ways that might be useful for you as a business owner tomorrow. Our goal is that you can walk away with maybe 2 to 3 different really clear paths where you could implement AI at your own business. And if you have any questions about that at the end, we will talk about office hours where you can come and brainstorm with us on other ways to advance that conversation. Let's just start with some basics here. The terms AI and ML are typically lumped together. William, can you just start by telling us the difference between the two and how they interplay and interact with one another?
Yeah, for sure. In rehearsing for this and thinking about what I wanted to say here, I tried to distill this down to the shortest possible definition. Like Marcy was saying, I think that people really overuse and overload these terms. And then you may have talked to engineers in the past and they may have looked at something that you thought was AI or ML and told you, well, actually, no, that's not real. My functional definition for AI to start is any software system or any device or robot or something like that that's trying to mimic human intelligence or is trying to represent human or animal type intelligence. And that's distinct from machine learning, which I think is software systems that can program themselves. And the way that that programming happens is through feedback cycles of learning, where you have a system that starts as a blank slate, you give it an input, and it guesses what that input means. And then you have a reward function that tells the model whether or not it understood the input properly or not. And then based on that, either positive or negative feedback, the model updates itself to hopefully make a better guess next time. And so you continue these successive feedback loops until that model has a very high success rate on the problem domain that you're dealing with. And so the connection between those two things is that we've observed that human and animal intelligence arises from this learning process and becomes generalized through the learning process. And so ML is these days often the foundation for a lot of modern artificial intelligence products, but they don't necessarily have to be the same thing. I'd say there are applications of ML, of machine learning, that are not artificial intelligence applications. And then there are ways of building artificial intelligence that don't rely on that learning feedback loop or that blank slate virtual brain model. A good example of an early AI in that category would be the early chess playing engines that were really built from scratch, written and coded by hand, or they were built around some preordained deterministic statistical models rather than being something that started as a blank slate and then learned how to play chess. So that's, I think, a really effective functional definition and distinction between the two terms.
You mentioned the word mimicking human intelligence. So it sounds like NLPs and LLMs have some subset of that human intelligence mimicking process. Can you tell me a little bit about what an NLP and an LLM are and how we can think about that as a subset of AI?
Yeah. NLP stands for natural language processing, and you could have a natural language processor, which is a implementation of a specific way of doing natural language processing. So I actually, you may have noticed, Marcy, I reordered this list and put NLP first because I think that understanding that problem is foundational to understanding what LLMs are trying to accomplish. Natural language processing is pretty much what it says on the tin, right? Your problem that you're addressing is, how do you get a computer to understand the same language that we use to converse with other humans every single day? And it's not obvious or even easy to do that because computers are ultimately like beefy calculators, basically. They're really good at taking numbers and adding them together. And when you get down to the very bottom of everything, the numbers that they're dealing with are just zeros and ones. And we have clever ways of saying, okay, this particular string of zeros and ones represents a number or a letter or some other higher order symbol, if you will. And so basically what you have to do with natural language, which is very unstructured and has all these nuances and branches in it, is figure out a way to encode it in a way that the computer can understand it and then do math on it and then turn around and give it back to you in natural language again. That's a very surface level explanation of the problem, but I think hopefully, just through the explanation I just gave, it's pretty clear how difficult that is. And it's really fascinated computer scientists and researchers for a long time. And I add to that, I think the holy grail of AI and machine learning and this LLM stuff is to ultimately create an artificial intelligence that is comparable to a human intelligence, or maybe even indistinguishable from a human intelligence. And so we have some examples of what are called narrow artificial intelligences, like the chess playing robot. And then we have with ChatGPT a much broader, more generalized artificial intelligence that can not only play chess, but can write code. It can ace the SATs. It can do all of these things that a normal human could. And so we're approaching, we're not quite there yet, but we're approaching this human level of intelligence and potentially a super intelligence. And that gets a little bit more philosophical. So I'll back off at that point. But just talking about natural language processing, that's the idea, is how do you get natural English, and it could be Spanish, German, it could be any natural human language into the computer in a way that it can work with it and then respond to you in kind.
That's been one of the most prevalent ways that we've been talking about implementing AI at smaller businesses, right? I think we've had probably 5 or 6 clients come to us to ask about being able to query a data set in normal language and then receive back a set of answers that they can feel excited about or sure about. And so we'll get into that at the end. But I think that idea of natural language being something that isn't reduced to a series of tags is something that has been really, in my opinion, shifted in the last 6 to 8 months that makes it feel much more possible. So headed down that route, I mean, obviously that's what ChatGPT really does well, is it explodes the ability of you to be able to Google things in some ways and respond with what we would consider an artificial intelligence. Can you just talk a little bit about ChatGPT, what it is and why people are so interested in it, and perhaps a little bit about why it's different than what has come before it? Because I think it does build on a long history, and it seems like it's exploded into the narrative in a way that others predecessors have not.
Yeah, for sure. I think that the explosion in the past year is almost entirely attributable to ChatGPT, and it's because it's such an incredible demo, right? And I'm sure everyone, I would expect everyone on this call has probably used it, and probably the first time you used it, you were like, "Wow, this is completely different from anything that I've ever seen a computer do before." And I think that just was a source of tremendous inspiration for not just technical people, but people outside of the tech field. And I wish we had included a chart here, but there's a chart that shows how ChatGPT grew to 100 million users faster than any other app ever. I think faster than TikTok, Snapchat, and things like that. I think ChatGPT is almost singularly responsible for the explosion in interest of AI over the past. Oh, that's great. Over the past year. But as Marcy alluded to, it took many, many years to become an overnight success, as the saying goes. And I think OpenAI as a company had been working on GPT type models for at least 7 years, at least since 2016, I think, if I'm doing my math right. And it was around that year that Google released a paper introducing transformer networks, which is, I won't go too deep into that, but like that's the core model that powers ChatGPT. So GPT stands for Generative Pre-trained Transformer. So the T part of that is the transformer. And Google casually threw this paper out there in 2017 and said, actually, this model we've developed seems to perform better on natural language tasks than any other model that's come before, and it's actually simpler. And OpenAI picked that up, and they started tinkering with that over the course of many years. And what they found is that the more data that they put into these transformer networks, and the bigger they made the transformer network, the smarter it appeared to become. And that is what resulted in GPT-2, which made a small splash in the tech community. Then GPT-3, which I saw a demo of 3 or 4 years ago, like when it first came out, and then didn't hear much for a while until the launch of ChatGPT. And at that time, it was just a prompt completion engine. So you would give it the first sentence of an article you wanted it to write, and it would complete the article. And so it wasn't the wow factor demo that we saw come out around November of last year with ChatGPT. The launch of ChatGPT was the result of over 50 years of thinking about artificial intelligence. Neural networks were developed as early as the 70s and 80s, and people were tinkering with them at that time. But some very important developments happened over the past 30 years or so that makes ChatGPT possible. Just to name a few of them, one of them is the internet. There was, in the 80s, no huge public data source that you could use to train a model like this. Another one is the explosion in computational power. Everyone here maybe has heard of Moore's Law, but the fact that we have exponentially more powerful processors. Another one is parallelization of processing and moving processing off of the CPU, the central processing unit, into graphics processing units, and then a better understanding of how to parallelize processing as part of that. And then all of this created a confluence, which gave us ChatGPT, is the short story. I could go deeper into that.
No, that's really useful. I think it's good for us to hear a little bit about what is similar in the past that you can draw parallels to, because I think to some extent it makes it feel a little more approachable. So when I started realizing that there are things that I already understand that are similar to ChatGPT, it made it easier for me to ask questions about it, but also easier to contextualize answers and see them as a part of a pattern. And so I think this is a helpful conversation for folks to be able to know how to ask questions about this type of stuff.
One thing I should say as part of that too is that the way that GPT works, and then as a result, ChatGPT works, is that I mentioned statistics earlier, it's fundamentally a next word prediction algorithm. So they fed it all of this data, and from looking at all that data in the context of where words appear relative to other words, the neural network, the transformer learned if I'm given a string, like an article, this is the most likely next word that follows at the end of that article, or what should follow that article. And then this is the most next likely word after that. And so that's how I think Lee called it performative speech. That is essentially what it's doing. And that gives rise, to answer your question, Lee, that gives rise to situations where the language model or ChatGPT may make things up, right? Because it's just guessing what the next, like that's how it was trained. It made guesses. It was told what's a good guess and what's a bad guess, but it doesn't really know in the sense that we think about knowing or reasoning. It doesn't really know what is true or false, right? And so it may string together a list of words that make sense and look good, but factually are completely incorrect, right? My first impression of ChatGPT was like, wow, this thing is a really well-structured writer. I've always been the grammar police, and I couldn't find any errors in its grammar. But then when you look a little bit deeper, you're like, what it's writing is a little bit vapid. It's not interesting. It lacks character, and it's often wrong. And it can't do math very well, for one thing, because when you ask it to do math, and that's surprising for a computer, right? But like when you ask it to do math, it's just going back into what it's learned and trying to string together words that look like they answer the question. So if you say what's 2 + 2, it'll probably tell you 4 because it's seen that a million times. But if you ask it something a little bit more sophisticated, it's just going to guess, and it'll probably be wrong. And so that's a very active area. I could probably say a lot more about that, but that's a very active area of research right now. How do we then like realign the LLMs and keep them honest, and maybe have them cite their sources, right? So that we can go and verify that what they are telling us is true. That's a big field and a big topic we could dive into if we have time.
Yeah, that's useful. Can you talk a little bit about what a neural network is? I think that term was really helpful for me in understanding the basics of all of this. And so let's just define that and maybe give a quick example of what that looks like.
Yeah, I think neural nets started to be developed around the 1930s, actually. And I think the first neuron was imaged microscopically around 1905. So we had a good idea of what neurons were about 100 years ago, and roughly how they worked, that they had synapses that passed signals on to each other. And so the basic idea of a neural network is to mimic that behavior of message passing between neurons, and the strength of the signal or connection between different neurons. A neural network is just an approximation of what goes on in a real brain, a mathematical approximation at that. It's super fascinating how well it works at scale, and to the point where, again, if we dig into the philosophy of it, there are many people who are beginning to wonder if our brains are just sufficiently large language models, and that these kinds of rules are all there is to it in terms of intelligence and consciousness, right? I don't have a strong opinion on that, but I think it's a really interesting idea. So yeah, so that's what a neural net is. Usually they have multiple layers, so they'll have a set of neurons in the first layer. All of those neurons will have values, and then all of those neurons in the first layer, neurons, right, in quotes, will connect to a set of neurons in the second layer, and in the third layer, and so on. You could have it be as many layers deep as you like. And as you train the model, those neurons update the values that they store intrinsically, and then they also update the weights of their connections to the neurons in the next layer. And so what we find is that basically what neural networks are doing when you feed them information and you tell them that they were correct or incorrect and they update themselves, what they're essentially doing is compressing that information and storing it in the values of those weights and biases, or what they're called, within the neural network. And so it's essentially storing computational snapshots of information. And what's really interesting about it is no one really understands how the data gets compressed and stored in there. When you analyze, I mean, that's also an area of active study, but when you look at the values that come out, or the values that are the result of giving it a certain input, it just looks like random noise, but the outputs are good. And so people refer to that as the black box problem of machine learning and neural networks, that it works, but there's no visible pattern to how it's working. My opinion on that is that, well, it's part of the training process is that you're introducing randomness into the system, and then you're mitigating that randomness over time, but you're starting from a random starting point. So of course you're going to end up in a random place, even if it works. But that's my lazy armchair opinion of that.
Okay, great. And then I think the last question here is, can we talk a little bit about what proprietary AI and ML is versus using some of these tools to build on top of these huge, crazy investments that have already been made in AI. I mean, I don't think anyone here on this call or in our close network is going to be reaching the scale of investment that creating a new model would take. So just a little bit about data management and those tools.
Yeah, some of the context there is that OpenAI partnered with Microsoft, and together they invested, I think, around $15 billion or more into not just, that covered the training of ChatGPT, which was a few million dollars, but it also covered building a data center and populating that data center with, I think, around 235,000 graphics processing units that are all wired together in parallel. So what's really fascinating is when you talk to ChatGPT, your text is being distributed amongst hundreds of graphics processing units, and then they're all concatenating their responses and sending that back to you and streaming that back to you. And that's just like Marcy was saying, that's wild and probably not very approachable for most small startups, if at all. So that's the value you're getting by paying OpenAI for using ChatGPT. They went through the trouble of collecting all of that data from the internet. They say they trained the model on all of the data of the internet, and there's some legal or ethical questions behind that. But they had the wherewithal to obtain that data, stream it through all of these GPUs, pay for the electricity and the space and time to do that, and tinker with it and do successive cycles of it until they got a good result. And so that's something you're paying for. That said, something I'm really excited about, and I think another attribute of this explosion of interest in AI is that we do know how they did it, right? Like, we do know about the Google paper. I've read the paper. It's not that complicated for a technical person. And it's something you can do at home. You can't download the whole internet, of course, but you can do small versions of this and really get a deeply intuitive understanding of how this works. And you can do your own science. And then from there, maybe discover something that works just as well as ChatGPT, but at a smaller scale. And there are some people working on that. I watched a fascinating interview with the founder of Fastmail, who has gotten involved. He then later founded Kaggle, which is a data science platform, and is now working on a project called Fast AI, which is making AI more accessible to everybody, the learning of it, and then also tools. And there's just been an explosion of tools that are available to every engineer now. So not quite at the scale or efficacy of ChatGPT or Bard or Bing or Cortana, whatever they're calling it at Microsoft, but it's a very approachable technology that still could have a business impact if you have the right technical people on your team or the right interest yourself to learn how to do those things. So there's been an explosion of tools. There are a lot more open source contributors to those tools, and it's extremely accessible. And as always, you can build or buy. So you could always go back and pay OpenAI if you want and don't want to get involved with those tools. But it's really exciting, all the things that are out there. One of the really fascinating things about the transformer model is that it is what's called multimodal. It does work on text, but it also seems to be working really well on images. And researchers at Microsoft discovered that ChatGPT 3.5 already was developing the ability to see images that you could feed it, and then also generate images. And then ChatGPT 4 actually iterated on that and can generate images as well. You can ask it to draw a picture of a unicorn and it'll make an attempt. It's not great, but these multimodal architectures are becoming more common, and other modes that also work just as well as images and text are audio. So OpenAI has Whisper, which is audio transcription software that is free and open source. I sometimes like to walk in circles in my backyard and talk into an audio recorder and just record my thoughts and do a weekly review or something like that. I bring it back to my computer and I can transcribe that offline because I don't want to upload my thoughts to some online service. And that is actually super easy to set up and use and do. So I think it's easy to see how a lot of these tools could be integrated into different types of apps. And I think an example of that, a good example of that I've seen recently is Loom. They have a really slick AI integration where you'll do a screencast, you'll upload your screencast, they will immediately transcribe it. I actually think they transcribe it while you're recording it, and then they will summarize your video for other people that you're sharing it with and automatically title your video. And I just as an example, I think fairly easy way to integrate AI into an existing platform that was also extremely slick and helpful and saves users a ton of time. We can go into more examples like that, but that just popped into my head as one of these modes where these transformer network AIs are making an impact.
So let's talk a little bit more about why people should care about AI. The first thing I want to talk about is this thing that we hear a lot, which is that all investment currently is going into startups that have some AI strategy. This is data from Carta, which is a tool that helps you visualize your cap table, but they end up having a lot of information then on valuations, data, and startup raises and rounds. And I just wanted to share this because I think that there is this narrative that you have to have an AI strategy to raise money right now. And I think that part of the reason that that feels true is that there is more investment in a seed round comparatively to the later stage rounds. And I think a lot of that is coming from the fact that companies that are working with a strong AI strategy are fairly new and are in the seed and Series A round. And so we're seeing fewer contractions in that market than we are in larger B, C, D rounds because there is this investment in AI that is coming and perhaps detracting investment from other places. One of the first things we hear about from our founders is how should I talk about AI with my investors and how can I think about my strategy in a holistic way, but also without making my whole business AI generated. And so I just wanted to call that out as the elephant in the room. It is easier to raise when there is AI on your deck, but I think a lot of that is a bet in AI as a broader topic, much the way that there was an investment in many crypto companies 3-4 years ago. And so, William, I don't know if you have anything to add on that, but I think that for me, understanding how you can take your business and how it's changing the specific user interactions and revenue models that you have and use AI as a strategy for that, I think is more important than figuring out how you can really be a new AI or build proprietary AI in that way.
Yeah, the only thing I'd add, just building on the Loom example, is the same process of thoughtful product development applies. Don't try to force AI into a product situation where it doesn't belong. People are already getting fatigued about the idea of chatbots or everything becoming a chatbot. And so before you build a chatbot, decide if that's the right thing for your product. To be investable, AI doesn't have to be a central focus of your app. Your app can do something quite traditional from a technical perspective, but then have AI, again, like the Loom example, have AI layered in a really slick and useful way that makes the experience that much better for users. The biggest promise of LLMs right now is as an interface tool, unless you get into that stage of where you're basically programming with AI, but that's, I think, too early right now to be accessible to most founders. But the very accessible thing right now is replacing parts of your interface, or potentially your whole interface, if it makes sense, with a language interface to make things more convenient and enjoyable for users.
Starting down that path a little more deeply, then I think there's a really big concern, especially in people who are not quite as engaged in ChatGPT or like techie, around data security. So there's two types of data security. One is our personal data being shared and stored and reused on the internet. I think that's one set of data concerns. So what happens to my customers' data if I use one of these tools that plugs into a larger network? And then the second set of concerns is if I have a proprietary strategy as a business, so I have a special way of teaching kids, or I have a methodology behind my coaching, if I share that with an AI, I'm essentially unbuilding my moat that I have spent time building as a business. William, do you have any thoughts on data security for both AIs, and then also perhaps how that trickles down to customer data security?
Yeah. If you're buying and not building, and even if you're building, you may need to purchase compute power from a third party like Google or Microsoft. Those are the bigger vendors of that, which means your data will be going somewhere else, right? And I think these days, people used to be really afraid of the cloud for that reason, and really old school companies still will not host their data in the cloud. I think that people are less scared about that these days, but be conscious of that, especially if you're dealing with sensitive data, like personally identifiable information for children or for medical records, like HIPAA compliance and things like that. So be aware of your compliance constraints, and then read the terms of service. When OpenAI first launched ChatGPT, they made no guarantees about what was going to happen with the data that you put in there. I seem to recall there were some instances where there were bugs in the interface because they were rolling out updates daily that revealed some of the chat messages that were sent by other users to different users. And if you have any PII in your chat messages or corporate secrets or something like that. That's a real big problem, right? The same is true for me as an engineer. I like to use GitHub Copilot, but I'm very careful about what code I'm working on with that. My code often includes literal secrets, passwords, and things like that. And so I don't know where that data is ending up. It's on a different server somewhere. It could be compromised already. Actually, I think Microsoft had a really big hack over the past couple of years. I don't want to say I'm defeatist about security, but it is an arms race, and there's only so much you can do sometimes. But it's definitely something that you should be conscious of, and especially as it relates to the particular data that you're working with in your business.
I think there's two other things then that AI can really help with, and one is speed of service. So one of the things that I think you mentioned, Loom, being able to immediately process transcripts back up, I think that is one of the key areas where you no longer have to wait and return to your service to see the end result. Do you have any thoughts on like the speed behind AI and anything about that we should be worried about or concerned about or excited about?
Yeah, so ChatGPT looks really fast, but like I was saying before, it's because it's distributing your workload over 800 computers. And so you will have a difficult time, I think, replicating that if you try to build it yourself. That's part of what makes it worth it to pay. This is not an ad for ChatGPT, but that's part of the value proposition of working with them. So yeah, be conscious that LLMs are in fact very slow unless you have that power behind you. So think about how that fits into your user's workflow. Is it going to be asynchronous where they don't need to sit around and wait for the AI to work, or do you need it to be really snappy, like the Loom example, and then plan accordingly? A good engineer can walk you through the trade-offs of that, and then also any technical hurdles that they would see to building the workflow that you want.
Speaking of good engineers and questions to ask, can you talk a little bit about how people can ask engineers about the accuracy of the AI that's coming back? I think there's a little bit of a concern that inaccurate data, like you said, is presented as if it were accurate. Are there fail safes that you can put in place that says how accurate data is or talks about how closely different pieces of AI are sure, quote unquote, about what they're doing?
Yeah. So I guess I'll start with something I didn't touch on earlier, which is that ChatGPT, for example, like GPT 3.5 or GPT 4 or Google's competitor Bard, these are considered foundational models, I think is the term that people are using. And what that means is that they were trained for the most general case on the most general data. They're not trained on your specific data. They probably never have seen it before. And so I think the best way to ensure the accuracy of the AI, if you're using a foundational model, is to bring your own data set and then be careful with how you prompt the model to retrieve information from that data set and talk about the data in that data set. Even then, if you have a chat interface where you're giving people the ability to inject their own prompts, they can break out of that and get back to talking to the foundational model, which has not only language knowledge, but also the collective knowledge of the internet, and then also the propensity to generate hallucinations or false data. I think there are mechanisms that you can put in place to wall off what the AI is looking at when it generates its response, and you can tell the AI, only include this in your response and say these specific things in your response and cite your sources and so on. That's the approach that I think works best right now. But again, this is an area of active investigation, and I'm sure there's going to be more commercial solutions being rolled out. This is still a frontier at the moment.
I think that's helpful context. We talked about processing power a lot. I think the last thing that I wanted to touch on is bias in AI. I think there is and has been for a long time concerns that if it's being trained on human intelligence has bias built into it. Is there anything that is emerging technology or things that people are trying to at least correct for that bias or expose that bias in a way that helps it be more obvious where the answers are coming from in a way?
Yeah, we haven't broken through this threshold yet, I don't think. OpenAI has maybe the best theory of this right now that they're actively practicing. They trained the foundation model, but then they asked the pure machine learning phase of training. They train it further or fine tune it further by interacting with humans who basically say, bad AI, don't say that. And so they'll say, okay, this is a good response. You're being polite. You're reflecting well, or you are aligned with human interests very well in the way that you phrase this response. And then they can tweak other responses that are not so good. I remember a couple of years ago, Microsoft released a chatbot on Twitter. I think it was called Sydney or something like that. and it was learning from other tweets. And within a day, people on Twitter, of course, got it saying vulgar things and racist things. And so it's really difficult because people can jailbreak out of the string of prompts or the fine tuning that the model has been given. OpenAI calls it the alignment problem, and that's like tangentially related to this idea of bias. We want to create AIs that have humans' best interests at heart and then also behave like good humans. That's probably the more difficult problem to solve at this point than the training problem.
That's helpful. I've been to a couple of talks on how the White House is getting involved in this as well and thinking about different ways that you can legislate for this. And so I think there's going to be a lot of changes in the next 3 to 5 years around that stuff. So that's, I think, something else to watch.
And it's probably worth like putting in a brief note here too, which is the ethical concern of where these companies that are training AIs are getting their data and who really owns that data. So DALL-E is super impressive. I played around a lot last year with Stable Diffusion, which has a public data set that's really interesting. And you can tell it to create art that looks like a particular artist, which means that particular artist's work is part of the data set, and it raises some really poignant intellectual property and copyright issues. And I'm sure many of those artists are not very pleased about that. So I think that's related to the bias issue.
Adrian asked a question here about questions that people can ask potential engineers and tech partners to talk about how can you get at whether they're just regurgitating AI 101 or whether they're actually taking this in and being strategic about the problems. Do you have any thoughts about ways that you like to talk about it or like to be asked about it?
That's a really great question. I would ask them what they've done. I mean, I think that's probably a blanket rule for all. Whenever I'm interviewing engineers for hiring, that's the number one question that I ask them is, what have you done? Can you show me? Walk me through it. How did it work? What was the hard part of this problem? That interview with an engineer tells me so much more information in a short period of time than anything else. And if they can walk you through a portfolio of AI projects that they've worked on that look like they're close to what you're trying to achieve, and they can show you a working demo, then I think from there you'll get a very good perspective on whether they're the right fit to work with.
I also think there's something to be said for talking about ways that it has worked in the past and also ways that it's failed in the past. So like you said, what's been hard about this problem, but I think in different industries, problems that have been solved, applying those to your industry is one way that you can see that potential strategic partners have thought through problems to the end, and then you can see how they would think through your problem. So I think that's a helpful way of thinking about it as well.
Yeah. And are they asking you questions and listening to you, right? Do you get the sense they're listening to you, or are they just trying to say, oh yeah, build a chatbot? Like, we know how to build chatbots, so that's what you should build.
Build a chatbot, that'll be easier.
Talking to engineers, whether it's AI or not, that's probably another good blanket rule, is that some engineers are not very good listening and they have strong opinions. So
I want to talk a little bit about how we have built AI here, and then also how you've seen other people building with AI. So I would want to keep this to a typical development team, though. Someone who has, let's say, 1 to 3 developers, what can they actually do with AI or machine learning, and not the 100-person teams, keep it a little more accessible. So one of the things that we have built a lot of is this wrapper around ChatGPT, where we send a training model in. Can you talk a little bit about those projects and how they work and control that data, as we alluded to earlier?
yeah, I reordered these as well, almost in ascending order of difficulty. So the ChatGPT wrapper would be if you're building a chatbot that leverages ChatGPT, and basically you build your own interface, but behind the scenes, you're sending every message over to ChatGPT, maybe augmenting each message with a special prompt that's specific to your app and to your use case. We've built a chatbot that gives financial advice. We suggested to the chatbot that it should behave like a personal finance coach, and it's actually pretty good at doing that out of the box, and gave it some other internal system level prompts. And then users would send in their financial questions, and it did a pretty good job of answering them. And has that evolved beyond that point at this point, Marcy?
A little bit, but I would say I think for that, the interesting question is, where do you stop using ChatGPT and where do you move into building somewhat of your own data network that it's mining? I think that's an unsolved problem that we're up against right now. But I think it was a really good way to test the customer interaction with the language, right? And figuring out, like, do my customers actually want to speak to a chatbot about this topic? And then how can I provide that data back in a really clear and concise manner that has my branding and my voice behind it? And so I think this is really applicable to anyone who runs a coaching service or who is thinking a lot about the way they do things. Like we've talked about building it at Think Nimble, like the Think Nimble CTO bot. It's a good way of putting your branding around a really robust set of data and being able to control the way that that data is represented to a client without having to build out every single thing that a customer could ask about and the particular answers that that person could be looking for.
Yeah, this is a really good way to test whether a chatbot is the right interface for your product, if that's what you think, because it's very lightweight and easy to build. And then moving up the hierarchy, recommender systems are something we've built for many clients, especially clients who have a two-sided marketplace or a two-sided data set. They'll have user data on one side and then content on the other side that they want to match those users to. Where LLMs fit into this is that they've unlocked this ability to take the natural language and then convert it into what's called an embedding, which is just a long list of floating point numbers. And then you can run classical similarity functions on those long lists of numbers to figure out which lists are more similar to each other. And you can use that to search a database of documents that have been encoded in that way. So that long list of numbers is just that embedding is just how the computer sees or interprets that natural language. I did a demo that I put up on our YouTube channel, just a plug, of using that approach to search through job descriptions for students. So on the one hand, I had a few thousand job descriptions. On the other hand, I had a few hundred students and their interests and the year they graduated and things like that. So I just took that unstructured data, plugged it into a search query, and then I get back a pretty sensible list of recommendations for jobs that those students should look at. And that's just scratching the surface of how you can use embeddings and LLMs to do that thing. That approach is similar to the bullet point 3 here, which is retrieval augmented generation. So it's using the LLMs to search a data set that you have, potentially using embeddings or a different approach, get back a list of results, and then summarize those results for the end user. So it's like a step beyond, you're recommending or you're querying a data set, but then when you bring back that data from that data set, you're asking the GPT to summarize it for the user or present it to the user in natural language again. One thing that I think is really exciting that's here now about LLMs is the ability to smoothly transition. There's some inaccuracy, but you can relatively smoothly transition from unstructured natural language to structured code, data structures that we already have a lot of solutions for. So as an interface that wraps around traditional technology, LLMs are really useful in that regard. And so one way that we're using that, when I talk about annotating data, I built a prototype, and we're doing this also for the jobs descriptions use case, where we're taking longer form text, asking the AI to extract keywords from those longer form text, which would have been a tedious process that a human would have had to do in the past. And then we can do keyword search, not just on the literal text in the keyword, but also on the conceptual, embedding of that keyword. A good example from the job descriptions thing is we would have a student who says, I'm interested in teaching. When we search the data set, we would get back professor jobs, we get back high school teacher jobs, we get back tutors. So it would also find things that are conceptually adjacent to the idea of teaching and not just the job descriptions that were literally only teaching. And then it would also, cross-reference their other interests and things like that. As an annotation tool, it's really powerful. With the multimodal architectures, you could also annotate audio, you could annotate images or videos and things like that a lot faster than you could do so manually. So that gives you the ability to scale your data sets massively. And I think that's a really powerful thing. And then transforming or summarizing data, I touched on that. But again, it's just that ability to move back and forth between structured and unstructured data. It's pretty good at taking unstructured prose language and then turning that into a JSON data structure that you could then send to an API or something like that. Again, it makes some mistakes sometimes, but it's surprisingly accurate. If you work with it and tweak it, you can get it to a very high degree of accuracy.
That's helpful. One of the ways we've also been doing that is figuring out how we can, basically the idea is if you could manually do something. So if you had 2 customers and they told you 2 things and you would recommend something back to them, I think the thing that AI does is allow you to do that at scale. So it allows you to do that hundreds or millions of times instead of dozens of times. So you're not constrained by time, which I think is an easy way to think about what unstructured and structured data could mean to someone. Structured data is something that you could put into a table. And I think the way that we typically make associations between things is a little more freeform than that. And so that's been the hard part of building technology to do those things previously. And then I think that's been really helpful, is you don't have to structure your data perfectly to get a good match.
Yeah, and the last bullet, you probably wouldn't use an LLM to do the audio transcription. There are AI tools that use transformers that can transcribe audio. And then once you have that speech converted to text, then you could process it using an LLM. So that's an example of how we've worked with that and done that.
Amazing. I think these are good jumping off places for how people could start to see this in their own companies. In the last 5-ish minutes here, 10 minutes, I just wanted to provide a list of brainstorming prompts for how you can apply AI to your current business. We talked about it being easier to fundraise when you have an AI strategy. One of the ways that you can talk about that intelligently with investors is by thinking about what you're currently doing that your customers are loving, or what you can't do at scale because you don't have enough manpower you have to hire for. And this list can help you think about those specific things in your business, and then how AI could help that go faster, further, or perhaps better. One of the things that we talk about a lot is making recommendations for customers. One of the things that we built for folks a long time ago was this ability to take specific responses from students and parse them together and make a recommendation for a potential way for that student to receive services from the school, a counseling service, or maybe financial aid, tutoring services. Those types of recommendation algorithms have really made huge leaps in the last few months or years. And I think that is one way to think about how you could apply AI to your business, is thinking about if you're making recommendations individually or at scale for your customers. AI is probably better or faster at that than you are. Another way to think about it is if you're thinking manually about relationships between two things. We have a client that we're working with that is looking at court cases at large and trying to figure out similarities between court cases in different jurisdictions, where there may be different language involved, different categorizations involved. And so previously you would see a list of cases for juveniles, but that would be defined as under 14 in New Mexico and under 17 in DC. And you can't really relate those two things well together. We have built an AI that helps relate those two things because of, like William said, taking that unstructured data, turning it into structured data, and then making comparisons at that point. And so I think that's also a cool way to think about how to add AI into your business, is the manual ways that you're making connections between things and potentially being able to do that at scale as well. Given those three, William, anything in there that you want to comment on in different ways that you could actually apply AI to those use cases?
So expanding on the example of searching job descriptions, one thing we actually did a multi-stage approach in the end, where we would tag the job descriptions based on job function, which was a set list that we came up with. So we didn't want the LLM to be saying software engineer in one place and web developer in another place or something like that. We wanted it to use the same tags and terminology throughout. So we started with that, and we were able to accurately tag a huge data set of jobs using that. And then from there, we created what I like to call a fingerprint for each of those job functions. And then on the student side, we had corresponding fingerprints that they generated from a survey that they took. So the fingerprint included things like how important salary is to them, how important creativity and autonomy and things like that are to them in the workplace. And then we scored the job functions accordingly. And so we're able to use a very simple matching algorithm to query our database of job descriptions based on that fingerprint, on that particular profile of the students. That I think is a unique way of searching. We're currently testing if that's a good way of searching it, but I think if it works, that's a really unique way of surfacing job descriptions to students that are a fit for their interests and skills.
When you say accurately, how did you measure that it was an accurate representation?
Well, we're working on that right now. But what's cool about these models is that to a certain extent, they can do what's called zero shot or few shot learning, where they can see something for the first time and give you a meaningful answer to it. But you should always be verifying whether or not that works for your use case. So what we're currently testing with actual users is whether or not the recommendations that surfaces are in fact a good, we have this hypothesis that fingerprint, that those 5 or 6 attributes of students and jobs are going to be a good match, but we're going to have humans in the mix. And actually, that's probably a big thing that we haven't touched on here, is that it's not a silver bullet. You'll need a human in the mix, and you'll need to be able to set these criteria for success for your AI. And again, I think that's just a good product practice, whether you're doing AI or not. You have to know why you're doing it and then have good firm measures for what success looks like. And this is no different, but I think it can really speed you up very quickly, especially if you pick the right path early on.
The last piece here that I wanted to touch on is talking about other ways that your customers might be looking for this. So for example, where are they waiting on you to come back and present them back with information? Or where are they giving you information and then you're taking that and transforming it somehow? An example here is that we are building an app that is an event planning app, essentially creating what you would call like your best friend's guide to the events that you should go to that weekend. So if there was someone in your friend group who was really cool and always had the best recommendations, they know you really well and they always provide you with like a great schedule of events. That requires information to come in from the customer. So you have to be able to know what the customer wants to go see. So I am someone who enjoys short events. I like to go to multiple events in a day, and I'm looking specifically to be able to meet people who are between 35 and 50 at those events. I have to provide you information for you to provide me back matching event. Right now, the way that that would have been done in the past is through a very structured set of tags. So you would go in and onboard and click 3 things, right? And those would light up. And then they would provide you with events back that directly matched those tags or were some combination of each of those tags. And so that's an example of a customer providing new information and you providing information back to them. A new way of thinking about that is being able to take in unstructured information and having that happen in more of a natural language conversation, and perhaps even a conversationalist style where the AI asks prompting questions to get you further into it. And then being able to match people quickly with the right event, even if those events aren't particularly tagged with the exact things that someone said. So I don't have to say the words 35 to 50. I could say the words mid-age or middle age, right? And that would be something that would come up there. So I think those are also interesting ways to think about how to apply AI to a more broad set of interactions that you're having with your customers.
I think Loom is another good example of that, where it would automatically title your video based on the content. And, 9 times out of 10, I'm like, yeah, that's good enough. That looks good to me. Let's move on. And so I think it's about finding opportunities, like Marcy said, to save your customers time and effort in providing data that you need to provide a good experience.
Awesome. The last thing I wanted to provide is just a list of things that we have been excited about on our end that are other AIs or people who are using AI in a cool way. And I think each of these are things that you could implement tomorrow at your business. They're low cost, low effort, but they're great ways to start playing around with AI and introducing it to your product process in a more robust way. The biggest one there is the Typeform AI. I think there is a lot of money poured into that, and I think you can tell. And so it may be something that can easily replace pieces of your product today. William, anything else you want to say to wrap up what we're doing here, and then we'll go into questions.
No, just I appreciate your interest and thanks for coming. And I hope this was helpful. Our emails are on the screen there. Feel free to email us if you have follow-up questions. And I'm always happy to sit down and write up more thoughts for you.
And then finally, we have office hours where we offer up an hour of our team's time to just talk through options. If you're curious about your specific use case in AI, you can hit this office hours link and we'd be happy to spend an hour and brainstorm